Well, hello students, this is Mr. Laws. I hope you all had a nice break. My wife and I had an opportunity to go to Europe, and the way things worked out, it's going to take a couple of extra days to get back to South Jordan. In the meantime, I've asked a good friend of mine to do me a personal favor and substitute while I'm gone. She is very good at math, and I expect you to treat her with your very best behavior. I will feel personally insulted if you don't behave. Besides, I have given her permission to take names of anyone who gives her any trouble at all, and I will call their parents when I get back. So please show her how good Elk Ridge students can be, and as a favor to me, do your very best. Thanks. Well, let's take a look at the topic for today's section. Here's the I can statement. I can compute areas of, we're going to use the word composite right here. Composite. So composite figures. Now there are some textbooks that use, and some people that use a different word, they call them compound figures. We're going to use them pretty much interchangeably, so just be aware if you hear somebody say compound figures, it's the same thing as composite figures. And we're going to start out with kind of a couple of review questions. They don't really have anything to do with today's topic, but it's always good to keep yourself on your toes and know how to do these percent problems. So the first one is about a coat. If a coat is on sale for 25% off, write an expression that could represent the new price. So we're taking 25% off the price, and there are a couple different ways to do this. One way to do this, and you'll notice that they never give us the price of the coat. Let's use C to represent the cost of the coat, and we're going to pay 100% of that minus the 25% that we get off. Now we can't just do minus 0.25 because that would be like subtracting 25 cents. 25% of the price of the coat. So this is going to be minus 25C, 0.25C. And again, if you realize there's that understood one right here, this is what we've got going here. We've got 100% of the cost of the coat minus 25% of the cost of the coat. That's one way that you could represent this. But then we could also take this and realize, well, if I used to pay 100% and we got 25% off, that means all we're actually going to pay is 75% of the original cost of the coat. And you'll notice that if we combine like terms here, 1C minus 0.25C, we end up with 0.75C, and that right there is probably the best way to write the answer. If we take a look at this one right here, this is now about a pair of shoes. I'm going to change colors for this one. If you have to pay 6.85% sales tax on a pair of shoes, write an expression for the total cost. Again, we're going to do this two different ways. So the shoes, I'm going to use S for the shoes. We're going to pay 100% of the cost of the shoes plus a little bit. Now remember, we've got to move this over two places, so careful there. 0.0685 times the cost of the shoes. Now my 5's and S's kind of look the same, so I'm going to do my best to make those look different. There's one way to write it, and again, you certainly don't have to put the 1 in front of the S or 1 in front of the C. But if we add these together, this is 100% plus 6.85%, so probably the best way to write this would be 1.0685 times S. That's probably the best way to do it. Now, this isn't on here, but I would challenge you to be able to do a problem like this. Let's come back up here to this coat example. It's 25% off, so this is actually how much we're going to pay for the coat. We're going to pay 0.75 times C, 75% of the cost of the coat. Well, when we get up to the register, they're going to take that 25% off, but then they're also going to add tax on there. So what if this is how much we paid for the coat, but we had to pay this much sales tax? Can you think of what we do to represent an expression for that situation? So let's think about what we did here. We ended up doing 106% of the cost of the shoes, 106.85% of the cost of the shoes. Well, we need to take this and stop and think about it. We're going to pay 100.0685, okay? So 106.85% of this cost right here. So I'm going to put that in parentheses, 0.75 times C. Now, we haven't done any problems like that, but hopefully that's not too big a stretch. If it is, stop and think about that for a minute, about why this would be a good way to represent the total price. We're only going to pay 75%, but then we're going to pay 100% of that plus a little bit of tax. So kind of keep that in mind. You might see a problem like that in the future, and it would be good to be able to handle that. Alright, now let's turn our attention to the topic for today, which is computing the areas of composite figures or compound figures. So the first thing I want you to do is let's draw a diagram of all the basic geometric figures that we've learned the formulas for in the last week or so, and let's label the important parts and write down the formulas next to each figure. So the first thing we're going to do is let's go ahead and write down about the simplest shape we can deal with, and that would be a rectangle. If we have rectangle, here's what we've got. We've got a base and a height, and we talked about how the area of that would be just A equals base times height. So area equals base times height. We also talked about if you take a rectangle and kind of push it over just a little bit, you get a shape like this, and that's called a parallelogram. So we've got a rectangle and a parallelogram, but this would still be the base. Now the height is going to look like this. The height is going to be how tall it is from top to bottom, so that's the height. And the area is, again, just the base times the height. We talked about how we can cut either one of these shapes in half and make a triangle. So if I draw a triangle, and I'm going to draw one that's a little bit atypical, we're going to use the base right here, and then remember how sometimes the height can actually be outside the triangle? And this triangle is exactly half of the rectangle with the same base and height. So we're going to do 1/2 the base times the height. You could also, if you wanted to do it this way, you could be base times height divided by 2. But I think we kind of focus on this one most of the time. So we're going to leave it that way. So we've got these formulas right here. I'll circle those because we're going to come back and use them. I think the next one we talked about was a trapezoid. So I'm going to draw a trapezoid in kind of an unusual way. I'm going to draw it like this, kind of draw it vertically. So I'm going to call this one B1, I'm going to call this one B2, and then the distance from the top to the bottom, straight from the top to the bottom, we call that H. And if you'll remember, the formula for that is the area is 1/2 of B1 plus B2. So that's the first base and that's the second base. Those are the two parallel sides. And then we're going to multiply that by H. So there we go there. And then I think the last basic geometric figure that we worked with was a circle. And we talked about how in elementary school you may have talked about diameters quite a bit. We usually represent the size of a triangle, or sorry, size of a circle just using the radius. So I'm going to mark this with an R right here, and then there were a couple formulas, and I'm going to write circumference right here, and I'm going to write area right here. And we talked about how these can be difficult to remember. They both have a pi, they both have an R, and they both have a 2 on them. So see if you can remember what they are. Go ahead and write them down. If you're not sure, just wait a second. So the way we said you could remember which is area is always in squared units. We're taking two measurements and we're multiplying them together like we are here to get area. So this is the one that's going to have the square on it. So the area of a circle is pi r squared, and the circumference of a circle is 2 pi r. So there are the formulas that we've talked about so far. All right. So now let's talk about what a composite or a compound figure is. So a composite figure, I'm going to change colors here. A composite figure is a geometric shape made up of more than one basic geometric figure or one basic geometric shape. And the cool thing about a composite figure is it can be broken into basic geometric shapes to make the area computations easier. So we're going to break these into basic geometric shapes. So let's take a look at this one right here. Note the instructions here. It says find the area round to the nearest hundredth. So we're going to need to be accurate to 2 decimal places. And then it says be sure to show what basic shapes you're using. So on many of these there's more than one way to do these. I think the easiest way for this particular one would be to kind of look at this and say, okay, we actually have 2 rectangles here. So I'm going to draw a little dotted line there. So I'm going to say we've got 2 rectangles there. Now you may look at this and you may notice a couple of other ways to do this, and we'll talk about those in just a second. But let's go ahead and do it this way. What we have here is a tall rectangle, and it doesn't matter if we don't draw it to scale. And then we have a small rectangle that looks like this. Let's mark out the dimensions on this. Well, this is 3.1 centimeters, and then we need to know how tall it is from top to bottom. Well, if you notice, they don't tell us how tall it is from top to bottom, but they do give us this. They do say that this side right here is 3.4, and this side right here is 3.7. So if we add the two of those together, you can double check me, but I think that's 7.1. If we do 3.4 plus 3.7, let's just double check and make sure. So we've got, clear this off, 3.4 plus 3.7. There's our 7.1. So that height right here from top to bottom, all the way from top to bottom, and notice the square corners and everything, this is 7.1. So we can calculate the area pretty quickly. We can just multiply the two of those together. Okay, now let's turn our attention to this one right here. You'll notice that this one it looks like it's a square, but again, in geometry you have to go by the information, not by the way things look. So this is going to be 3.8 here and 3.7 right here, and let's multiply those together. So I'm going to do both those problems at the same time. So we have 3.1 base times height, 3.1 times 7.1. Let's see, 22.01. 22.01. Okay, so 22.01. And notice we're already rounded to the nearest hundredth, and then we're going to have 3.8 times 3.7. So we'll do the 3.8 times the 3.7. There's the base times the height there. So this is going to be 14.06. So 14.06. You'll notice that I haven't kept track of the units very well. This is centimeters, centimeters, centimeters. So this is centimeters squared, and this is centimeters squared. So if you stop and think, we found this area right here. Then we found this area. I'm going to change colors here. We found that area right there. And what we're going to do is we're going to add the two of those together. So I'm going to take this answer right here and this answer right here. We're going to add those together. And if you add those together, we end up with 36.07. So notice that we're already accurate to the nearest hundredth, centimeters squared. So there's a perfectly good answer. Now, I said we'd come back and take a look at this a couple different ways. That's the way I chose to break it up on this particular one, but there are a couple other ways to do this. You may have seen this. Well, hey, can't we do this? Break it into 3 little rectangles. That would be totally okay. Generally, we want to do it as efficiently as possible, so you might want to keep that in mind. Doing 3 is probably going to take us a little bit longer than this one right here, so that would be one thing we could do. And then if you look at it and you think of this in a little bit of a clever way, you might see another way to do this. And that would be, let's take this big one right here, let's find the area of that, and then instead of adding like we did over here, let's subtract this small rectangle up here. Now this one's 3 by 8 and 3 by 4, so we could find that area pretty easily. In order to find this area, we've got to know how far it is from here to here, so we have to add the two of those together. So that's going to be 6.9, 3.1 plus 3.8. And then we'd have to know how tall it is. Remember, we already figured that out. That was 7.1. So if we did it that way and we did a little subtraction problem, we're all set to go. It will give you the same answer if you wanted to do it that way. So I'm going to put an or right there. It's going to work out to be the same way. So let's take a look at this one right here. This one, they've done us a favor right here. They've actually already drawn this with the shapes that we're going to use. So we're going to use, let's see, what's that called again? Half a circle. And we're going to use a rectangle here. Actually, take a look at this. This is a square, 11.6 and 11.6. So we've got a rectangle there, or sorry, a square there. This is actually called a semicircle. Okay, I hear that all the time, but that's what it means, half a circle. So we're going to find half of that area. Now remember the formula for area, it's 1/2 the radius, or sorry, it's pi times the radius squared. That would be the whole circle. So the whole circle would be pi times r squared. So we need a couple of things. First of all, we don't need the entire circle. We're going to take this and we're going to divide both sides by 2. So we also need the radius. The radius goes from here over to here. So we need to figure out what that is. If from side to side it's 11.6, we're going to take that 11.6 and divide it by 2. So that means the radius equals 5.8. Let me just double check that. Yep, 5.8. Okay, so if the radius is 5.8, I'm going to make that look really nice, hopefully. 5.8. Here's what we're going to do. We're going to find the area here. So the area of this one is going to be 11.6 times 11.6. We'll go ahead and do that one. 11.6 times 11.6. You might be able to think of a quicker way to type that into the calculator. 134.56. So we're accurate to 2 decimal places there. That's good. And let's see, this one right here. This is going to be pi 5.8 squared, and then we're going to divide that by 2. Remember, we only need half the circle. We don't need all of it. So let's type this into the calculator. We're going to do pi, and pi on my calculator is right here. Hopefully you remember on your calculator where it is. So I'm going to hit second and pi so that I get that to pull up. And then I'm going to do parentheses 5.8, close the parentheses, and I'm going to square that. Okay, that is the entire circle. I don't need the entire circle, so we're going to divide by 2. So here's what we've got, 52.84 and all this extra stuff. So if we're going to round to that decimal place right there, we look one past that, and is that enough to bump this up to a 5? So the question here is, do we have 52.84 or 52.85? Well, since that's a 1, that's not enough to bump that up, so we end up with 52.84. So 52.84. So that's the area of the half circle rounded to the nearest hundredth, and that's the area of the square. Didn't have to do any rounding. And then we'll just add the 2 of those together. So we're going to take 134.56 plus 52.84, and we get 187.4. 187.4 or 0.40, and that's going to be centimeters squared on this one also. Alright, so hopefully you can kind of see how we break this up into these smaller shapes. And let's take a look at these. A couple of these are kind of unique. This one right here, most people would look at this and there's kind of a nice breaking point right here. What we've got is we could just draw a line straight from there to there. So we have a rectangle up here, and we have a parallelogram right here. So if you break it up into two, this is what it would need to look like, and this is going to be 8 by 6. If we slide this one down here, that's going to be 6 also, but then we don't know how tall this is. So the question here is, how far is it from here to here? Well, if you stop and think about this, this would be 8 here also, and if it's 14 from top to bottom, it's got to be 6 from here to here. So the height on this one has to be 6. So we're going to do base times height. That's going to be 48. I'm just going to put it right there. Base times height, that's going to be 36. I'm just going to put it right there. And then we're just going to add those together, 48 plus 36. Now while I'm adding those together, you may want to look at that and see if you can come up with a different way to do that. Answer is 84. No rounding involved, and this is in centimeters. Looks like a lot of these are in centimeters, so that would be centimeters squared. Remember, area is always measured in square units. Spend a little bit of time thinking about this, and maybe a way where we could kind of modify this figure a little bit so that we could do it in one single step. Kind of a little challenge that I'll throw out to you there. Let's take a look at this last one on this side. What we've got here is a quarter circle. You'll notice that the radius is 11.2, and then we've got a triangle, and that triangle, they've given us pretty much all the information. The base is 12.1, and the height, which is the same as the radius over here, is 11.2. So we're going to do 1/2 the base times the height, 11.2, and then over on this one, tell you what, we'll come back to that one right there. Think about how we're going to do that one in just a second, because that's a quarter circle. So let's see, we have, I'm going to do 0.5 for the half, and then times 12.1 times 11.2, and I end up with 67.76. So 67.76, and then this one right here, that quarter circle, let's see, the area is pi r squared, but we only want 1/4 of that, so let's divide that by 4. So here's what we're going to do. We've got, again, pi, and then the radius is 11.2. We didn't have to divide that in half like we did the other one because this is the radius right there. It goes from the center out to there. So we're going to do, let's see, times 11.2 squared, and then we're going to divide the whole thing by 4. Now you've got to make sure that you type it into the calculator correctly. We get an area of 98 point, let's see, 52 or 53. That's a 0, so we're not going to bump that up. So this is going to be 98.52. And then we're just going to add the two of those together. So we've got 98.52 plus 67.76. And we've got 166.28. So 166.28. And again on this one, oops, different unit, meters squared. So there we go there. All right. Now, as we flip this over on the other side, I want you to take a look at the instructions. Okay, I think you'll find this kind of nice. Show how you would find the area, but do not compute the area. All you need to do is just kind of think of what would be the most efficient way to break this up. So if you take a look at this one right here, they've kind of got some heights right here and stuff like that. We could figure out how tall this one is. This is probably the best way to break it up. To draw a line right there, you're going to find a big parallelogram and a small parallelogram. You can easily figure out that this one would be 10 because the whole thing on the bottom is 22. This is 12. That's got to be 10. You can figure out that the height here is 8. So the whole height here is 9, so this one here would have to be 1, and then we could compute it that way. But you do not have to actually go through and compute it. The best way to do this one would probably be kind of lop off those triangles at the end there, compute these triangles, which if you think about it, those would have to be exactly the same, so you could just find one and double it, and then find the area of that little rectangle in the middle. And lots of different ways to do this one. One of the best ways to do this one is probably, if they're telling you how far it is from here to here, let's take that triangle there, and then we're going to find the big rectangle, and then we're going to subtract this one right here. So unlike this one where it's find the parallelogram and add the small parallelogram, and on this one where it's find the triangle and maybe double that, okay, so I'll put it right here, and then add that rectangle in the middle. This one might be better done using a subtraction problem. So now we're going to take a look at kind of an interesting problem, and if you know how to compute areas, I mean, these really go pretty quickly. Once you get used to these, you're using your calculator a lot and things like that. I'm going to show you a problem right here that hopefully you find kind of interesting, and this really is the value of knowing these geometric formulas, because at some point you're going to be interested in doing a problem like this, and it would be nice if you knew how to do it and didn't get ripped off when somebody came in and measured or something like that. So here we go. Janice needs to replace the flooring in her living room and hallway with carpet squares. A floor plan is shown. What is the total area of the floor that needs to be carpeted? So Janice has kind of a unique house. It's got this rectangular hallway, which is pretty standard. Then this big kind of rectangular living room, but then this semicircle that's off to the side there. So if we're going to compute the area, this is probably the best way to do it. Let's cut off that little hallway. Let's cut off that little semicircle, and then let's draw the pieces. Here's the hallway. The hallway is 3 feet by 12 feet. Here's the main part of the living room, that rectangle, and you can see right here that this is 18 feet. And then from here to here, let's see, we need to know how tall this is. Well, they don't give us a measurement on this side, but if you come over here, if this is 3 feet, let's slide that over there, and that's 3 feet. So 3 feet plus 9, let's see, yeah, that's 9. 6 feet plus 3 feet, 9 feet. And then add this, this is going to be 14 feet right here, so that's going to be 14. And then we've got that semicircle right there. And the only thing we need to know about the semicircle is what's the radius. So let's see, this is 8 feet, and this is 18 feet. That means from here to here is 10. So that means from here to over there, that's going to be half of that, so that's going to be 5. So the radius on this is going to be 5. So here are our formulas. We're going to do base times height. So that's going to be 3 times 12. We're going to get 36. And that's square feet, remember. Then we're going to do this one. Grab the calculator, double check we got that one. We're going to do 14 times 18. So a lot of square footage there. We've got 252 square feet. So 14 times 18, and we've got 252 square feet. Got that one there. And then we've got this little semicircle. So that's going to be half of the area of a circle. So we're going to do this. We're going to divide both sides by 2, and let's throw that in there. That's going to be pi 5 squared divided by 2, and let's get that on the calculator. So again, pi, and then we're going to do 5 squared, and then we're going to divide by 2. And your calculator knows the order of operations, but it would be a really good idea to get that right. Let's go ahead and round to the nearest hundredth. So this one, we finally end up with one that we've got to round, because that's a 269. So that is enough to bump that up to a 27, so 39.27. So 39.27, and that again is square feet. Okay, so if we add all those together, so if we add the 36 and the 252 and the 39.27, if you add those together, we're going to end up with this. I've got the answer here, 327.27 square feet. So that's how much area we need. We're going to need to recarpet that with carpet squares, and that's what we've got there. So Janice goes to the store and she needs to buy the carpet squares. Each box of carpet squares contains 9.65 square feet of carpet. How many boxes should she buy? And this is good to keep in mind, and this is true in real life. They only sell full boxes. They're not going to sell you just one carpet square. Okay? So each box has 9.65 square feet of carpet. So we need to figure out how many boxes. So if we've got 327.27 square feet, and it's 9.65 square feet in each box, we're going to divide by 9.65, and that's going to tell us how many boxes we need. So let's go ahead and plug that into the calculator. So we're going to get, clear that stuff off, 327.27 divided by 9.65. Now this always happens, 33 boxes and a little bit more. Now since we can't buy a partial box, we're actually going to have to buy, we'd have to round that up to the nearest whole number, the nearest number of boxes. So we're going to have to buy 34 boxes. 34 boxes. One box costs $32.95. How much will the flooring cost? Well, if we've got 34 boxes and they're each $32.95, we're going to have to multiply those together. And you can kind of see where this is going. We're going to find out what the total price is by the time we leave the store. So this is going to be 34 times 32.95, and we end up with $1,120, and don't forget this right here, let's write it down the right way, $1,120, $1,120, and we don't just leave it 0.3, it's 0.30. So there we go. Now, to finish this off, what if she has a coupon for 20% off? How much would the flooring cost? Well, that's actually going to save a heck of a lot of money, and let's do this the quickest way we can. We would normally pay 100% of that price, but we're going to get 20% off. So that's going to leave 80% of the price. So let's do 0.8 times 1120.3, or 30 if you want. So 0.8 times 1120.3, 896.24, 896.24. So that's a pretty big savings, from over $1,000 to less than $900. That's pretty cool. But then there's one more question. I'm not going to make you do this, but what about tax? Tax in the state of Utah is that 6.85% in most places. So it might be a little bit of a challenge. See if you can come up with the total price including tax. Hopefully that helped. If you need to, you can watch this again and pause and rewind in the parts where it maybe didn't make as much sense as you needed it to. But good luck on the assignment. Thanks.